Okay, so now let's go on and actually verify Green's theorem for these two vector fields. What do I mean by verify? What I mean is I want to calculate each side of the equation and compare them. They should be the same. So I'm going to start on the left here, and we have this vector field that we're going to look at. Let me keep the color here in blue. So I've already written out over here what we're looking for. The circulation form of Green's theorem tells us that on the left-hand side, the circulation, which was 2 pi, should equal this, which is the double integral of the curl, the two-dimensional curl. So I need to calculate gx and fy. So let me go up here and actually just calculate all of the partial derivatives. Fx, well, f does not depend on, so how did I get f and g? Let me back up here. This is f and this is g. Okay, so now fx, this does not depend on x, so that's 0. Fy is -1. Looking over here now, gx, this is 1, and then g does not depend on y, so gy is 0. So now I can put that result in here. Gx here is 1 minus fy, 1 minus -1, so that's 2. And then I see that I can just pull this 2 out, and then I'm taking the double integral of 1 dA. Remember, this is one of the properties of our double integrals. This just gives us the area of the region D. The region D here, as we saw up here, is the unit disk. So the area of a disk is pi r squared, but the radius is 1, so we just get pi. So this area of the region D is pi, so I get 2 pi. So indeed, that does match with what the circulation value we had gotten earlier is. So great, this one checks out. And now let's look at the flux form of Green's theorem for this particular vector field. Here I'm going to use the divergence as the integrand. So I want to calculate fx plus gy. Fx is 0 plus gy is 0, so this is 0. So the integral is 0. So again, that also checks out. Great. So we verified Green's theorem, both flux and circulation form for this vector field. All right, so now let's do that over again for the vector field over here. This is the explosion one. And let's remind ourselves that we had calculated 0 and 4 pi for the quantities that are going to be on the left-hand side, the circulation on the left and the flux on the left of Green's theorems. Okay, so now we're going to go down here and then calculate the partial derivatives. This is little f, this is little g. There we go, and then let's just take the partial derivatives. Fx is 2, Fy is 0, f does not depend on y. Gx is 0, there are no x's in here, and then gy is 2. And so now I go down here. So starting again with the circulation form of Green's theorem, we had found the circulation to be 0. So that's the left-hand side. And it equals the double integral of the two-dimensional curl, which is gx minus fy. So gx here is 0, minus fy, that's also 0. So I get 0, and that makes sense. Verified that part. And then now we go to the flux form. The flux form is, on the left-hand side, we had calculated this to be 4 pi. So there it is. And it's the double integral of the two-dimensional divergence. So fx plus gy. Fx is 2 plus gy is 2. That gives me 4. Similar thing here. I pull the 4 out. I'm now integrating 1 dA. This is the area of the region D. Back to that same calculation. D is a unit disk. Its area is pi. So this is 4 times pi. So 1